It's Friday, it's the AWS Developers Podcast. Today we are talking about agentic AI, Amazon Bedrock, and MCP, Model Context Protocol. Good morning. Thank you for listening to the AWS Developers Podcast. We are available every Friday morning in all good podcast applications. Please subscribe. Tell about the podcast to your colleagues, your friends. The more we are, the more feedback we receive, the more useful content we can produce for you. Today, I have not only one guest, but I have two guests to talk about a hot topic of the moment, MCP. Unless you lived in a cave for the last few weeks, you probably heard and read and maybe experiment already with MCP. We are going to talk about that, but as usual, trying to fit MCP into a business challenge that our customer wants to solve and see how it integrates with existing tools such as Amazon Bedrock. And actually, you wrote a blog post together. That was the starting point. That's why I contacted you saying, hey, can you come to the podcast and explain what you did? So thank you for being here. On one side, I have Giuseppe Battista. On the other side, I have Kevin Schaefer Morrison. You're both solution architect in the startup team. You're working with early stage startup in the UK. Thank you for being here, gentlemen. I don't know which of the two of you is going to answer my first questions, but maybe let's start with the business challenge. Your customer startups are massively adopting generative AI. What are the challenges they have to do so?
Well, it's incredible to see how fast these companies are actually integrating AI into their workflows. One of the things that really pushes me to learn more and more and more about AI is that their demands are becoming more and more opinionated, more and more insisting on, what are the best practices for integrating AI. And from time to time, I don't even know myself. I need to spend a lot of time in doing my research, reading. So this is not only finding the business case, but it's also how are all of the other players moving in the industry. And it's incredible to see so much buzz around agentic. I have a few examples of customers that are building, for example, marketing and ad tech workflow to automate a lot of the undifferentiated operations that are around their, say, monitoring of their funnel, or creating campaigns, or getting into the validation of their campaigns. That is one of the really interesting applications that I've seen so far. There's a company that works with us that is building ads within chatbots, and they're really interesting how they're making use as well of agentic workflows to monitor the conversations. So from ad and martech, that's an interesting perspective.
I feel like every industry and every customer is talking about how they can use AI right now. So I think it truly is ubiquitous in the different domains and topics that we come across. And I think the topic of how to move quickly and then also how to expand and do more complicated workflows is one that in the last few months has been really, really interesting. And I think that's exactly where things like MCP and agent workflows are going to be really interesting.
I have a customer that says an AI assistant assists you. That's a large language model. It's able to generate text, summarize, classify, and things like that, while an AI agent act on your environment. An agent is code and can do whatever code can do, call an API, make a booking, or fetch real-time data about something. But what are the challenges to integrate agent inside an AI-based solution?
Okay, I'll try to take that one on a topic that I'm really, really passionate about, which is observability. All of the various frameworks that I've seen so far, all of the various implementation that I've seen so far, they kind of had to come up with a way to build observability frameworks around agents, which I think it's, as a problem, it's not a novel problem in the industry, but the amount of chatter that is coming out of these systems and the challenges around storage, the challenges around context and memory management I am really passionate about. It's really, really interesting to see what's happening with some companies that are trying to recreate the way the human brain actually manages memory. So ideas around long-term memory, short-term memory, and also thinking about maybe semantic caches that will, in a way, limit the amount of data that you are throwing to LLMs. That's quite interesting. To give you an example, I've worked recently with a customer who's dealing with corporate surveys, and one of the things that they want to achieve is to make sure that all of the input from employees is bubbled up to leadership so that leadership can make better and data informed decisions. But one of the limitations that they ended up bumping into is the fact that a lot of the input that is coming from employees is semantically the same. So the meaning of that is quite the same. And like, how do we limit access, or like, how do we limit the bandwidth of information that is going to the agents themselves? So those are like two of the main challenges that I've seen. It's about like observability. It's about storage of history, storage of memory, memory management, and providing punctual access to context and memory. I found all of these topics really fascinating.
I think another piece of this, if we take a step back towards software engineering, which is truly my roots, when you add in agents to a workflow, it's naturally more complicated. There's more pieces to the puzzle. I think in a way we're so used to, at least those of us that used to program, are so used to building very deterministic systems. It's if this, then do that. And it's very clear exactly what the system is supposed to do. With agents, it's a whole new world. Deterministic workflows are more or less a thing of the past. But it gives you all this new flexibility of being able to do so many more things. But the question that you asked, Sebastian, was around what makes agentic workflows and workloads and agents and such more complicated and difficult, and what are the challenges? Another one is hallucinations at scale. So imagine you have 5, 10, 15 AI interactions that are happening in a single agent workflow, and they're all interacting with each other. You're essentially compounding what could be hallucinations. So the thing that Giuseppe mentioned of observability and understanding the way your system is going to work and being very precise in what you're doing is extra important when you start doing agentic systems, or ones that are chaining more and more non-deterministic operations together.
And how do your customer manage to do that? You work obviously with a lot of startups in the field, so you are a really good observer of the state of the art in this domain right now. Orchestration, you mentioned it, Kevin. That's one of the key words we have. We have a bunch of agents, a bunch of tools, whatever we call them, and we need to build a business workflow that use these different agents. What are the options customers have today?
Yeah, there's a handful of different options out there these days. So the Amazon Bedrock tool has a agent capability, and then there's a bunch of open source libraries that you see. But the thing that I talk to most startups about is not which framework are you going to use. It's first, let's understand what it is you're trying to solve and figure out what is the minimum viable boundary of what this application is doing. So for those of you that are familiar with moving from, say, a monolith to a microservice pattern, one of the first things you need to do is find the bounded contexts of your application, which is what are the individual things that are happening. So when you talk to these startups that are building, they do the same concept when they're starting to work on the agents. It's what should a small action be that one of these agents needs to take or figure out how to take, and then figuring out how to connect them. So we like to start small with those very basic concepts. And this is a beautiful bridge into the topic of MCP, which is a protocol that allows you to actually connect these large language models to these individual little actions that you're going to be taking. So the step one is figure out what are these little actions, how do they need to be orchestrated at a high level, and then the next step is figuring out how to actually interface with them, which is again where the MCP protocol comes into play, which I'm sure we'll get into a little bit more depth in a minute here.
Is it similar to think about how to split a monolith into a couple of microservices and decide what is the responsibility, what is the perimeter of each microservice? Are we just transposing something that the industry knows roughly how to do since like a dozen years to a new concept, but the foundations are the same? It's the same type of problems we are trying to solve.
I personally think that that's a really, really good analogy and parallel to what people have been doing. And I'm assuming as time goes on, we'll get more nuanced opinions on it. But I think that's a really, really good place for people to start and to grasp onto something that's a familiar concept. So in favor of moving quickly, I think that that is a fantastic way to start thinking about this.
But with a big difference is the non-deterministic, that's difficult for me to pronounce, non-deterministic aspect of it, where in a traditional workflow, I know exactly the interface of my microservice. I know the sequence. I can draw the sequence, and I know I have to map the output parameter of service X to the input parameter of service Y. I know the types and everything, where in an agentic workflow, it's the LLM that is going to decide that for me. So the result might be a bit, I don't know, maybe different at each execution. So that's one of the challenge.
If you are able to map exactly a workflow to like some sort of deterministic flow chart or something like that, you're definitely not in the territory where you are going to need agents. I think actually I was on a talk the other day delivered by Diana Alvarado, a colleague of us. She's a fantastic generative AI specialist here at AWS. And she's giving this overview of the level of autonomy of AI. And she's put together a complexity framework that is pretty much similar to, when you're thinking about the level of autonomy of a vehicle. So we're talking about level 1 all the way down to level 7. Level 1, you have what you could think of, a simple chatbot that is reactive, and it will reply to your questions, and it will reply punctually to your question, but maybe it's not context aware. It doesn't have any access to memory. And then we're moving then to level 2, which is the capabilities that Kevin was hinting at, and what we are going to dissect in more details today. Tool using, for example. So how do I enable my AI system, whatever shape or form it is it agentic? Is it just an application that is augmented with some AI capabilities? But once the LLM is into the picture, that is actually able to execute some pieces of code, and that's level 2 all the way down to level 7, which are like the
Can you explain, I interrupt you, from a developer perspective, what is tool using? What type of API? I think it was ChatGPT that start, OpenAI that start with that API. It's now quite pervasive across different platforms. And it's available in Bedrock as well. What does it mean to write a tool for a large language model?
I think the most simplistic form is a way for the LLM or whoever is orchestrating the interaction with the LLM to invoke a piece of code. So running some piece of code somehow to invoke, let's say, a deterministic flow. I think that's what comes to mind when I'm thinking about tool use, to give you a pretty, let's say, hello world style example. You can see out in the wild a lot of tools that are getting, for example, the weather forecast from an open weather API. The reason for that is, LLMs, or like the way that you're producing LLMs or you're training LLMs is really expensive. It takes a long time. And within the parametric memory of that LLM, you will have some knowledge embedded, but you will not be able to get the most up-to-date information. And This has been tackled, I guess, at the beginning of 2020 with a very foundational paper called Retrieval Augmented Generation, in which we are asking an external source, which is potentially more up to date than the parametric memory of the model, to bring in some context. And this way, for example, you could implement some sort of RAG workflow by actually using tools, by getting information from APIs that are storing that data, or like providing the data in a structured form. The other option that comes to mind is the calculator. We know for sure now, with the latest Anthropic paper on the biology of a large language model, that these models are not able to perform simple arithmetic, right? They simply don't have that capability up to this point. And this is where you might want to enhance.
Yeah, they invent the
Yes,
answer.
they probabilistically get to an answer that is convincing, I would say. That's, hallucination. It's kind of a feature of this sort of technology. If you ask a model to perform a simple arithmetic operation like 2 + 2, if it's left alone to its own means, it will hallucinate to the answer that is more plausible, or maybe it's already available in its training set, or somehow available to their parametric memory. But actually, if you want to provide it the actual capability of performing arithmetic operation, what you can do is do what, as software developers we do best, which is actually writing a function and accepting these two parameters, performing the algebraic operation, and returning a result. So in a nutshell, I think this is what it means to provide a tool, or having tool used to an LLM.
It's funny that you mentioned that example, because that was my first experiment with tool. I wrote two very simple tools. One is able to calculate a cosine, the other a sinus of an angle. And then I was amazed by the capabilities of the model, because if I asked to calculate a cosine or a sine, he knew that I had a tool, and he asked me to invoke the tool and provide the answer. That was okay. But then I experiment a bit more and I say, hey, can you calculate a tangent of an angle? And I didn't provide a tangent tool, but it used its general knowledge to tell me, hey, to calculate, I cannot calculate a tangent, but I can help you with the tools that you provide me. First, calculate the cosine, then calculate the sinus, and then I will assemble the two and make the division and return you the tangent. And I was amazed the first time I saw that, to say, wow, the model can actually orchestrate the different tools for me.
That's a fantastic example of the creativity and ability to use the tools together in a way that when you were starting to tell the story, I was like, oh, he's going to have to make a tangent tool. But in the end, it just used the tools available to understand that there's a relationship between those things. That's a really fun example.
Oh yeah, I had the exact same aha moment that you are describing here. So I provided my model with a few different tools to operate on blog posts. For example, I had one that was validating a link, or another one that was actually downloading text from a web page. And when I asked the question to the model, hey, can you please go and summarize and validate all of the links into these blog posts at this particular URL, the model actually looked like it was planning to execute those tools in sequence. And I think that this is I would say an emerging characteristic of the model itself, rather than having an explicit orchestration.
When we were preparing this podcast episode, we talk about different tools to orchestrate different agents. We mentioned Crew AI, Small Agent, Pydantic AI. In this podcast, like in November last year, I also interview Corneliu and Anthony from the prototyping team that developed a multi-agent orchestrator, a very popular framework to orchestrate agents. But with the reasoning, the thinking capabilities of large language model, do you think we don't need these tools anymore? Do you think that a large language model can now be the orchestrator of our agents?
I think that's a really interesting question to pose. And I think we'll learn more as time goes on. It's an ever evolving landscape. I think you will still need something to coordinate your application because there's usually multiple layers of complexity and problems that you're trying to solve. And you don't want to throw an entirely nuanced, very complicated problem at a single model and hope that it can sort out the chain of thought and then invoke the correct tools that you've created. Where if you can orchestrate and break down your problems a little bit more atomically, you'll likely be able to get better results and less hallucinations, which I was alluding to before. And that's what a lot of these frameworks give you flexibility to do. That being said, I mean, I've interacted with all the different frameworks that you've mentioned there, and they all have their own nuances of complications, things that they're good at, opinions, which is a thing that we talk about all the time in software packages. And maybe you disagree with the opinions of the way that these frameworks work, or you need to do something outside of what they support, which then maybe you're going to do your own thing. But the short answer to your question is, I think as these evolve, we'll get a little bit more clarity into what you should or shouldn't be using.
So you would probably suggest like a layering approach where you, at high level, there is like one of these tools, an orchestrator tool that split the task into smaller tasks, and maybe these smaller tasks are small enough to delegate entirely to a large language model where they can do the orchestration of that subset of the task. Did I understand correctly?
Yeah, that's a good simplification.
Just a big shout out to Corneliu and Anthony. I think they did a great job. Now I think the multi-agent orchestrator has now been renamed as the Agent Squad, and it's for those who don't know it, it's an open source orchestrating framework that I've found extremely useful in providing agentic capabilities to existing systems, especially if they're sitting already on AWS, like your Lambda functions that you may have already developed, some API-backed systems, even Lex chatbox. So if you're building in AWS and you want to get started quickly, you was using open source tech. That's my go-to, and this is what I've been suggesting to my customers as well.
Yes, and they have like huge libraries of different connectors to different systems. You mentioned Lambda, there's S3. So it's very easy to integrate all the existing technology, tools, API, whatever we name it, inside our workflow. Kevin, you mentioned the acronym that I mentioned also in the introduction, MCP, the big buzz for the moment. What is MCP? How it fits in that in that model of a workflow and different tools and a large language model?
Yeah, so the example you gave earlier of you made a tool that can do cosine evaluations and a tool that you do sine evaluations is a very simple hello world style example, right? In these more complicated systems, you're going to need lots of tools to do all sorts of different operations, whether it's call complex APIs or invoke sub-processes. And likely you're not going to be running them all on the same machine that you're invoking your model from. We're going to want to scale things out. So if you think again back to the microservice pattern, a lot of services are going to be communicating with each other, and there's usually a paradigm of communication. And MCP is the parallel that allows you to basically have a client application, which is where you're going to be running your main chain of thought model invocations and your main entry point. And then you're going to be able to use the MCP framework to communicate with tools that may be running on remote servers, APIs, other applications from other companies. Essentially, it's just a protocol to connect your application with remote tools.
So MCP is a protocol that helps a client, an entry point, to take your vocabulary, to invoke a tool locally on the machine or remotely over HTTP.
Yeah, I like to think of it very similarly to the way that, if you're running a classic application, you hit an API endpoint using a HTTP GET request. The concept from the engineering perspective is very similar. It's just a new protocol that is designed to do these tool-based communications. And something you mentioned earlier, Sebastian, is we need to understand the inputs and outputs from each one of these tools. And that's one of the things that the protocol is also going to be communicating when you make these requests. The MCP framework that Anthropic created, there are really nice decorators for Python and interpretation of the comments, so you understand, oh, this tool requires 2 input parameters, they're of this type, and then it has these output parameters, such that you can communicate effectively back and forth with the models and the tools and actually have communication that makes sense. And you're not losing type, you're not losing inputs or output parameters because it's a model guessing what a function does.
For me, that's a bit of magic because you, as a tool developer, you just give a textual description of what is your tool, of all the functions that you propose, be endpoint, or it's not an endpoint, it's really like an individual API verb.
Yeah.
And the argument, input and output, with a textual description of the argument. A weather tool, hey, this is a tool that can give you the weather, current and forecast weather. It accepts one argument, which is a city, the name of the city where you want to get the forecast. And based on that, the model is able to figure out, oh, that tool will help me to answer that question, but also to extract the individual value inside your question, like the name of the city, and to tell the client that is invoking the model and the tools to say, hey, use that argument to call that tool. It looks like magic to me.
And the thing that I really like about it coming from a developer background is the magic you just mentioned scales really well as your team grows. So you can imagine you have 10 teams that are all building their own tools. As long as they build the definition that you were just explaining very concretely and clearly, all they need to do is say, hey, client server that's going to be telling the model that this tool exists, here it is. And as long as you're using the MCP protocol for communicating between the client and the servers, it does kind of feel like magic. And you can scale your teams really, really, really well. So I think it's a fantastic way to grow these applications with flexibility, add new tools all the time. You can remove tools, but the protocol really enables that.
I saw some people comparing MCP to USB. USB is the physical specification that allows to connect all type of device, from power to hard drive, mouse, keyboard, whatever. And MCP does a bit the same in between large language model and actual tools. Would you agree with that USB analogy?
Yeah, and I think it is becoming the standard at the moment. I mean, the library that Anthropic released just came out in November, so not even 6 months ago, and it already has really, really taken off. So I'm only assuming it's going to become the standard and very analogous to the way USB has taken over device communication.
There is another analogy that you mentioned, Giuseppe, during the preparation of this episode, which is a split brain analogy.
Yeah, if you're a fan of a popular neuroscience like I am, I think I know that this is probably going to make some professionals laugh, but I think with LLMs we achieved some of the access to the functions that our right hemisphere is usually responsible for. I don't know if there's any new research that is going to blow that out, but in my current parametric memory, I associate with the right brain, the imaginative or emotional, the intuitive, creative, and the management of the creative language or language itself. Whereas, and this is where what LLMs unlocked for us on machines. And as I was saying, hallucination is a feature of LLMs. I still have to see an LLM that's able not to hallucinate out of the box. But I guess that what we have been doing as software engineers for a very long time is actually building together all of those deterministic flows. And so computers were traditionally really good at logic computation or arithmetic computation, mathematical function, anything that is kind of predictable and you can draw down as a flowchart or a recipe. So I think that MCP is kind of acting as a bridge. There's a part in your brain called corpus callosum, which is a large bundle of nerve fibers that basically facilitate the communication and coordination between the two hemispheres. And I'm thinking of NCP. Like that, it's a bridge between
the left part
and the right
of
part.
your brain.
Yes, yeah. I think so. But if there's any neuroscientist in the audience, please reach out to me and suggest something better. For now, this is how I conceptualize it to myself.
So let's try to summarize everything we talked about before. LLM are really good at producing text classification, summarizing, but also splitting a complex problem in smaller steps. But they can just produce text. If we want to act on the reality, we need code. We need something that is able to call an API. And what a tool API can do with a large language model is let the model tell you, hey, use this tool. But at large scale, we need first to coordinate many of these tools. We might use frameworks to do that, or we might use for, if I follow you correctly, Kevin, for smaller use case, we can use the reasoning capabilities of the models itself. But then the next problem is how to call all these tools. If they are local or remote, we need a standard glue, a standard protocol to call that. And that's where MCP enters. And it just entered a few months ago and looks like it's everywhere. Now we have repositories of MCP server. We have more and more MCP client. Visual Studio Code is an MCP client. Cursor is an MCP client. And we have many tools that are clients. It means they can just plug into any MCP tool server produced by someone else and magically work. But there is an elephant in the room there. What about security, authentication, permissions, and all these type of things?
Yeah, that's going to be a really important conversation as this evolves. The people that I've spoken to about it at various startups are only using their own MCP servers that they have deployed privately inside of their own firewall subnetworks, so they don't have to worry as much about the authentication process. But as you're using these third-party ones through marketplaces, that's definitely going to be an important thing to consider. Make sure you have safe connections, you're using secure transport clients, and yeah, don't let that get in the way of anything.
We had a debate in my team recently. I was advocating saying, hey, there is nothing different than with microservice. If you expose a microservice to the external world, or if you're invoking public REST API, you need to be authenticated, and the good old OAuth and JWT token technology still apply for MCP servers. So what is different with tools?
I think it's the management of the credentials and the fact that these are close to autonomous systems that I don't think we still understand fully. And so we're used to build threat models for deterministic systems. I think that this discipline of like mapping infection vectors and where all of the threats are coming from is an evolving discipline as well. And I'm also thinking about the fact that within the specification right now of MCP, the security aspect is delegated. So I think that inherently in MCP there is a go-to-market promise, and I think that this promise will only be settled or will only be realized when the security aspects of all of this will be nailed down and are also, I would say, aligned with the requirements of large enterprise customers or large, heavily regulated customers. I'm thinking of customers in the healthcare space or in financial sectors. So this is an evolving debate. I mean, you can follow the pull requests on the specifications as we speak, and it's kind of amusing to see the debate that is going on right now. But there are, I think, inherently the go-to-market and the kind of channels that this is opening is really, really promising.
In your blog article that I mentioned at the start of this episode, you were trying to bridge Amazon Bedrock with MCP server. What is the specific challenge to do so?
So the main challenge is to provide your MCP server with an endpoint to an LLM provider, and Bedrock does exactly that. It's excellent at doing that as its main job. And we do have the Converse API, which I think it's a fantastic abstraction layer on top of all of the, let's call them dialects, that all of these models are speaking. And the Converse API, they have a defined interface, which in some places is a bit different from the specifications of MCP. So the first challenge, I would say, is just to map the capabilities of the Converse API to what the protocol is expecting. And that's nothing.
It's a pure translation. You transform the JSON returned by an MCP server to the JSON expected by Amazon Bedrock Converse API. Okay. That's not very challenging.
No, absolutely. And I guess the other was building a client that conforms to the expected flow of conversation. It's interesting to see, again, like those emerging capabilities of planning from the model that are a consequence of how a conversation is built with an LLM. So Bedrock is able to provide you with the reason for which the generation has been stopped. And in this case, the reason that you should expect when you want to invoke the tool is a tool use request. And the flow is pretty simple. So the model will stop and think, will evaluate the tool that are available in its arsenal and say, hey, probably I should be using this tool to calculate cosine. And it will send back a response through the Converse API suggesting the client receiving this message, hey, actually, you should be invoking this tool that you have promised me you have. And so that's how the next step in the flow, that's where you are delegating to the MCP infrastructure that you put in place to invoke the right tool. The response comes back and it is added to the chat history at this point. It is provided back to the model. The model analyzes or hallucinates on the response, and that's how the flow basically is built. And this is where I think the planning capabilities are emerging. And yeah, to be honest, it wasn't much of a challenge to integrate that. I think the only thing that you need to do is understand this new paradigm of building software, which is around the conversational flow.
Yeah, the actual code, as Giuseppe said, is not particularly complicated. However, it did take us a couple iterations to make sure that we were communicating with the Converse API correctly. So the flow of ask initial question to model, then model responds with, oh, I'd like to use this tool and here's why, then invoke tool, then respond back to model. And eventually you do have to follow model says, okay, I'm done. Here's my final thought on the topic. Coordinating that in a loop was not difficult, but it's just actually wrapping your head around the way that it's working was the harder part. And it's non-deterministic, but in the code,
it is
exactly. And once we sort of bridge those two gaps, I think the rest of it just sort of came really easily.
I have a disclaimer to add. We are recording this episode on April 11, and this is a space that changes literally every day. So by the time you're listening to this, there might be different things. There might be MCP first class support in Bedrock. I don't know what's coming up. I'm not pre-announcing anything. I'm just telling you that the state of the art might be different by the time you listen this and the time we record it, because it's really changing every single day today. Have you already prototype workflows, agentic AI workflows with MCP for your startup customers?
Oh, I have one which is really, really interesting, and I cannot disclose too much, but
No.
it has to do. No, it has to do with finding information about, I would say, artists around various sources, various websites, and even looking for internal. Um, um, internal data sources, and so because all of the like these artists may not have all public presence on all of these social media or different website, or they may have something. So there's almost clearly a need for an agentic workflow, in the sense that your agent will start with I would say maybe an initial exploration, like a gathering facts about this artist, and then once it has gathered enough information, then it will decide, oh, okay, I'm going to have a look at their Instagram page, and maybe if there's a relevant video about the topic that I want to write an article about, or I want to write their update their bio page or something like that. So it's basically an agentic workflow that is looking into doing deep research, but I would say that all of the channels that it has to scout through are not necessarily listed. So I would say it's a best effort deep search, and I find that quite challenging, because with normally with a deterministic flow, I wouldn't be able to map it, or like I would have to write a lot of like fail safes or default case, or like manually curate a list of data sources. Whereas in this case, my starting point is going on DuckDuckGo and making a query.
We are all working in this space since only a couple of months by definition. I think it was you, Kevin, you said it as MCP protocol came only in November last year, so it's like 6 months ago, but it's buzzing since a month. During that month, what did you learn? What are the main challenges, the lesson learned so far? Of course, I understand it's an evolving field, but as of today, what are the things to keep in mind?
So I think the thing that we touched on earlier with authentication is going to be an important one. But I think the things that I've seen that are more evolving and more problematic is not about the MCP framework. The framework is rather simple in terms of the protocol.
That's correct.
It's more of around orchestrating things and the tool usage. And if you give 100 tools to a model, or you describe, as Sebastian, you were saying a little bit ago, of the magic of explaining what the function does, sometimes the model is very eager to use a tool when it may not need to. So I was talking to someone literally yesterday who had to reprompt a bunch of things because they found that one of the tools that was doing an expensive third-party API call was being called way too frequently. And they had to then reorchestrate and replan to make sure that they weren't overusing that. So I think that is something that the models are probably going to get better at, understanding when to use the tools. And then people are going to get better in the kind of new form of not prompt engineering, but tool definition engineering, which is a very interesting new concept. But I think that's going to be really important in the coming months.
Is it a future job title, like agent developer or tool orchestrator?
Tool description developer, something like that. Yeah,
no, but
I'll take that job title.
It's kind of the extension of prompt engineers. Last year, everybody was talking about prompt engineers, and we realized prompt engineering is only just one part of the problem. If now with the vision we have on tools, there is maybe a bit more than just crafting the correct prompt.
Yeah, it's a whole ecosystem of this new text-based engineering, which is really curious, really interesting, and I love watching it evolve.
Vibe coding for the win.
That's something different. And I'm sure I will have an episode on vibe coding as well, because I have tons of things to say, and I would love to hear others' experience as well. Vibe coding, if you never heard about it, it's the coding with an AI assistant that does the code for you. So you just prompt what you want, and something writes the code for you. And as much as I was skeptical, like a year ago, as much as I have fun now because I'm developing tons of things that were in my backlog. I had never the time to do it. And now I can do it in 10, 15 minutes, 1 hour. What's next? We talk about prompting, agentic collaboration. I was talking with a customer last week. Are we going to revisit enterprise workflows in the future? Are we going to a system where IT enterprise are a collection of agents that collaborate? It's difficult to predict the future, I know.
I've heard somebody saying that, cloud service providers will basically become HR for agents. I cannot for the life of me, and I'm sorry to whomever I'm stealing this quote from, but I cannot remember who said that. I think it's a over-optimistic view of the future. I'm more siding with Okta's CEO, who the other day said, there is ever going to be, there's the demand for engineers is just going to grow in the future. We will need more software engineers, not fewer. Probably what a software engineer is going to do, or like what their responsibilities are today, are going to change radically. I kind of side on that side of things, which I'm pretty optimistic about the figure of the software engineer. It will change, but I think with the proliferation and the acceleration at which companies are, creating new features, creating new products, that's only going to increase.
I think it's going to increase. I think there's kind of trade-off curves that happen as well in terms of cost of actually operating these agents, because the compute is not particularly inexpensive at the moment. But if you look at the cost of models over the last 2 years, they have indeed generally gone down. So I'd expect that trend to continue. And then, you have the trade-off against human capital of actually doing the things. So I'm expecting to see a lot more of these workloads. Is it going to take over everything in terms of like enterprise workloads? I don't know exactly how it's going to go, but we're seeing way more of it. Everyone I'm talking to, that's all they want to talk to me about these days.
One thing is sure, there is a bright future in front of us, including for software engineering. I totally join your point of view. I don't think the demand for software engineering will decrease and I think that's one of the reasons of this, the success for MCP as well. It put back the software developer in the middle of the game, where like for the last 2 years, we were saying, hey, we don't need software developer anymore, software engineers. And now we see that, if we want to get some value, we need tools, and tools at the end. Sorry, it's still code. Even if we have AI assistants to help us to write code faster, we still need people that understand how to code. That's a fascinating conversation. Thank you, gentlemen, for highlighting the business challenge of the startup, the early stage startup you're working with, and how tools can help to build an AI agentic workflow, how MCP fits into that, and maybe what the future will look like, at least the short-term future. Giuseppe Battista, your solution architect for the startup team in UK, together with Kevin Schaefer Morrison. Sorry, I have to say your full name. You're in the same team, solution architect for startup. Thank you for having listened this episode until the end. Give us feedback, share the episode with your friends, with your colleagues, and download the episode next week, next Friday. But now go build.